Hello dear students, in today's video lecture we will study about BSR. BSR stands for Bank Select Register. So this is just the abbreviation for Bank Select Register. So as far as PIC microcontroller is concerned, this BSR is one of the most important register. So each register in the data memory has 12-bit address. So as it is of 12-bit address, it allows up to 4 KB of data memory. It allows up to 4 KB of data memory. So as we already know this, okay. So data memory map is basically divided into 16 banks. See here you can see the data memory map is divided into 16 banks, and these banks are of 256 bytes each. Each bank is of 256 bytes. So the BSR, it holds 0:3. It means these are 4 bits. Okay. So these are the upper bits, and remaining 12 bits will have the address of RAM. So as the lower 4 bits are of BSR, which are used to select the bank, and upper 4 bits are basically not implemented. Okay. So as 4-bit BSR gives us 16 banks and each is of 256 bytes, we can cover entire 4 KB of memory. So how it is possible? See, how much banks are there? 16 banks are there, and each bank is of 256 bytes. So 16 multiplied by 256 is equal to 4096. Okay, it is equal to 4096, and which is almost equal to 4 KB, right? So we are saying that it can cover the whole range up to 4 KB. So 4 KB of data RAM are organized, okay, in 16 banks. It means they are organized from 0 to F. 16 banks. Okay. So 0, 1, 2, 3 and so on. Then after 9 we have A, B, C, D, E, and then we have F. It means 0. Okay. From 0 we have up to bank F. These are 16 banks in number. Okay. These are 16 banks in number, whereas this 0 is nothing but bank 0. This 0 is nothing but bank 0, and this is nothing but bank number 15. Why 15? Because we have started with bank number 0. Okay, so from 0 to 15 it is 16. Okay, so basically move LBK instruction is used to select the bank. Okay, so which bank we are supposed to select? For that we have to use a instruction move LBK. So I'll just tell you about that instruction also. And again, important thing to be noted that there is an access bit of the instruction that is called as A. It means see, this is a small a. Okay, notice it properly. So small a, when it is 0, BSR is ignored. Okay, it means we have to use the access bank. Whereas if bit is equal to 1, it means we have to use BSR, that is bank select register. So basically we have a access bank. This is just a virtual or the imaginary bank which we have. So when the small bit A is equal to 0, BSR is ignored, we have to utilize the access bank. Whereas if bit A is equal to 1, it means we have to use a bank select register. So here you can just see the nature of bank select register. Okay, you can see the nature of bank select register. As I told you that it is a 12-bit register. Okay, as it is a 12-bit register, you can see here from 0 to 7, it means these are 8. Okay, and from 0 to 3, these are 4. 8 plus 4 is 12. Okay, but these these 4 bits 0 to 3, these are used to select the bank, which bank we have to utilize. So depending on what binary number will be written over here, we have to select the bank. and here you will have the RAM address of 8 bits. Okay, so here you can see your data memory is there. You can see this bank 0, bank 1 up to bank 15. These are 16 banks in number. So how to select that banks is more important. Now see, the lowest bank is bank 0. You can see it here. Lowest bank is bank 0, which is having the address from 00 to FF. It is having the address from 00 to FF. And in similar terms, which will be the highest bank? Obviously bank number 15 will be the highest bank. Okay, so it will be having the addresses from F00H to FFFH. Okay, so in between also you can see all the banks, because I told you about bank number 0 and bank number 15. In similar terms, you can see the addresses, the minimum and the maximum ranges of the addresses. Okay, now suppose if BSR is equal to 0, it means these are zeros. Okay, these are zeros. It means, see, this is a binary number. Okay, so we are writing this for 0. Okay, which indicates that the address of data RAM from 000 to 0FFH. So if this is 1, it means bank number 1 will be selected. What will be the RAM locations? RAM locations will be 100 to 1FFH. In similar terms, you can select the banks. That's the reason, as it is of 4 bit, okay, as it is of 4 bit, 2 raised to 4 is equal to 16. So we get 16 possible combinations. So 16 banks can be selected by changing the binary numbers over here. Okay, so now see how to load this BSR, okay, is important. And I told you about the instruction move LBK. This is the instruction which is going to help us to select the bank. Okay, so in order to load the 4-bit value, see, we want to select, suppose say bank 1. Bank 1 we are writing it as like this, 0001. So this is a 4-bit value and we want to put this value over here in this BSR, bank select. Okay, so at that time we have to use the instruction MOVLBK. Okay, so to load the 4-bit value in a BSR, move LBK instruction is used. Okay, with this instruction we can load into BSR the value representing any one of the 16 banks. Whichever bank you want, you can just see the equivalent binary number of that, use this instruction and load it into this. This means the values will be between 0, 0, 0, 0 for bank 0, and continuing with bank number 1, 2 up to bank number 16 will all be ones. Okay, for bank number 16 it will be all ones, that is FFFFH. Okay, so see, in order to access a memory location from one bank to a memory location in a different bank, you have to switch the bank, that is a bank switching is required. Okay, so in order to access suppose F56H, if you want to access this, okay, this address F56H in bank F from the address 15H, okay, which is in bank 1, it means this is in bank 1 and this is in bank 15. Okay, the programmer must change the bank number. The programmer must change the bank number. Why? Because 150H was in bank 0 and F56 is in bank 15. Okay, it means we have to change the number over here depending on the requirement, and it is accomplished by using this instruction, that is move LBK. So K is a 8-bit number. You can see this K is a 8-bit number. Okay, K is a 8-bit number. The lower 4 bits of K are used to specify the bank and upper 4 bits are always cleared to 0. see, as this K is of 8 bits, okay, it will be consisting of 8 bits. It means only 4 bits are used of that K and 4 bits are always cleared. Cleared means they are set to 0. So the lower 4 bits are used to specify the bank and upper 4 bits will be cleared. Okay. So switch from bank 1 to bank F. Switching from bank 1 to bank F, we have to replace the value of K. Okay. So we want bank number 15, that is 0FH. Okay. So how we will write it? We will write it like this: move L B, and what is K? I told you K is 8-bit number. Okay, 8-bit number. So it is 0x, which bank? It is bank number 15, which is indicated by 0F. You can see it here in the standard format. Okay, so here you can see only the lower 4 bits are used, whereas the upper 4 bits are cleared to 0. So above instruction, it will load 0FH into the BSR and will select the bank number F. This value will be loaded into the bank select here, and then it will accordingly select the appropriate bank. So in order to select this bank, we are using this bank select, and these 8 bits are used for the RAM locations. Okay, so this was all about a bank select register. So this is one of the most important register as far as the PIC 18F458 family is concerned. Thank you.